Hey, 2Algebra, this is Mr. Berta here. Welcome. It's Monday, February 8th, 2021. We've got a short lesson, asynchronous lesson for you today. And it's really just some more practice. We're going to be looking at some more rational functions, identifying the vertical and horizontal asymptotes, identifying the y-intercepts and the x-intercepts. And specifically, we're going to look at some that have multiple vertical asymptotes. So go ahead and take a look at these three videos. If you feel like you've already mastered it, go ahead and jump ahead to our homework. The homework tonight is the day 7, 4-2 day 7 online homework assignment that's also in Google Classroom. So grab something to write with or print off the PDF that's in Classroom and we'll get started. All right, let's take a look at number 2 here. I'm going to find this rational function right here. And the first thing I want to do to help me out, I want to identify the asymptotes. I want to identify the y and x intercepts, but I want to first see if I can factor either the numerator or the denominator. And in fact, in this particular example, I can actually factor both of those. So the top here, I notice that 4x squared and 9, those are all perfect squares. So the difference of squares rule is making an appearance here. Hopefully you guys remember the difference of squares rule is the following, where it's a squared minus b squared. That can be factored as a minus b times a plus b. So this is exactly what we have in this situation here. We've got the 4x squared. Well, the square root of 4x squared is 2x. And the square root of 9 is 3. So we've got a 2x minus 3 and a 2x plus 3. That is the difference of squares of that particular numerator. And then in the denominator, we can kind of factor it just in the old-fashioned way. We're going to start off with putting x in the front here. And I see that two factors of 15 are 5 and 3, and those differ by 2. So I'm going to choose those as my factors. I see that the 2 is positive, which tells me that the 5 must get the plus sign, and the 3 gets the minus sign. So now I have factored this rational function. The next thing I want to look for are the vertical asymptotes. All right, do we remember where to look for to find the vertical asymptotes? We look to see what is going to make the denominator equal to 0. That's how we find the vertical asymptotes. And here we've got two factors that we can look at that will definitely help us out with that task. So, and we can just go one by one. So the first factor is x plus 5. We can set that equal to 0. If I subtract 5 from both sides, you get x equals negative 5. And that is the first equation for the first vertical asymptote. You can see we've got a second factor in the denominator, which means we're going to have a second vertical asymptote. But the same procedure applies. We just set x minus 3 equal to 0. Here I'm going to add 3 to both sides, and x equals 3 is the second vertical asymptote. So we have two vertical asymptotes. Let's take a look now at our horizontal asymptotes. Do we remember where to find the horizontal asymptotes? We find the horizontal asymptotes. Well, it really depends. Remember, there are those three cases, and it depends if the degree of the numerator is less than, equal to, or greater than the degree of the denominator. Here, we have a situation where the degree of the numerator, I'm just going to abbreviate it like that, is 2, and the degree of the denominator is also 2. So those two degrees actually equal each other. When we have that situation, we know that the horizontal asymptote is y equals the ratio between that numerator and denominator of the lead terms, leading coefficients, we'll say. All right, so here, what's our ratio? We've got a ratio is 4 in the numerator and 1 in the denominator. So it's 4 to 1. That means our horizontal asymptote is just y equals 4. Next up is the y-intercept. And we find the y-intercept by plugging 0 in for x and then solving. So here, which of these formats is easier to calculate when we plug 0 in? I would say it's this traditional form over here, because when we plug a 0 in for x, look, this term becomes 0, this term becomes 0, and this term becomes 0. And all we're left with is a ratio. So I can write f of 0 equals -9 over -15. Right? That's what we're left with. Now this can be simplified. -9 over -15. That can be simplified if we divide both the top and bottom by -3. We get 3/5. All right, so that tells me that our y-intercept is 0, 3/5. And the last thing we want to find are the x-intercepts, also known as the zeros. And for there, we're looking for what is going to make the numerator equal to 0. What is going to make the numerator equal to 0? So here, the factored form will help me out again. I see I have two factors. I can go one by one, setting each of them equal to 0, and we will find the x value that gives us a y value of 0, which is will help us find our x-intercept. So the first one here is 2x minus 3 equals 0. If I add 3 to both sides, I get 2x equals 3. And then if I divide by 2, I get x equals 3/2. The other one is 2x plus 3. Set that equal to 0. Subtract 3 this time from both sides. I get 2x equals -3, and then divide by 2 again. I get x equals -3/2. So that means I have two x-intercepts, and the x-coordinates are 3/2 and -3/2, and the y-coordinate of all x-intercepts are 0. Let's go ahead and graph this function using our graphing calculator. So I'm going to open up my graphing calculator right now. You can see I've already typed in the function f of x into my y equals screen. So pause the video now if you want to do that to catch up, but I'm going to go ahead and hit graph. And here's what we get. Okay, I just pasted our graph here on the note sheet. And the first thing I see is we did a great job finding the vertical asymptotes. We found one at -5. We found another one at x equals 3. We found a vertical asymptote at y equals 4. And we also found x-intercepts at positive and -3/2, and a y-intercept at the point 0, 3/5. And all those key features seem to check out on the graph that we got using our graphing calculator. So great job on this one. We've got 2 more videos on the next 2 slides.